Example number 8. F of x equals to x minus 1 over x squared minus 3x plus 3. The maximum degree of the numerator is 1, x to the 1, and the maximum degree of the denominator is 2, x to the 2. So degree of the numerator, which is 1, is less than the degree of the denominator, which is 2. Therefore, my horizontal asymptote will be 0. Y equals to 0. My horizontal asymptote is 0 here. Remember, sometimes we put limit here, as we did in the previous examples. Like here, limit of x squared where x approaches positive infinity. Or limit of 2 over x squared plus 1 where x approaches infinity. It is just to check that whether the limit exists or not. My suggestion is that don't even put limit here. Just directly put f of x equals to 2 over x squared plus 1. Don't try to limit here. Put f of x equals to 2 over x squared plus 1. Because look, if the function is in fractional form, normally the limit exists. But if it is not in fractional form like here, x squared is not in fractional form. When you directly put x equals to positive infinity, you will get infinity. Your answer will be infinity. It is not a real number. It is limitless, therefore the limit does not exist. In such case, we don't have vertical asymptote and horizontal asymptote even if there is no hole. So I don't think so it is important to put limit here. Just put f of x equals to x squared. F of x equals to x minus 1 over x squared minus 3x plus 3. I didn't put limit in front of this function. Since the degree of the numerator is less than the degree of the denominator, according to the rule, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is 0. Therefore, my y equals to 0. My horizontal asymptote is 0 here. But let me show you an xy plane. At y equals to 0, I have this red dotted line. This is my horizontal asymptote. So I can write that horizontal asymptote is 0 here. Again, when you look to the function, can I do factorization here? Yes, I can do factorization. Check the function. Is it possible to do factorization? Yes, when you look to the denominator, I can simplify it and make the factors out of it. So let me do it. It equals to x minus 3 into x minus 1. X minus 3 and x minus 1 are the factors of this denominator when you simplify it. The first step has been done. But what about the second step? Cancel the common factors. Do I have common factors here? Yes, I have. I have x minus 1 in the numerator and x minus 1 in the denominator. Just cancel x minus 1 with x minus 1 in the denominator. Cancel x minus 1 with x minus 1. So I will left only with 1 over x minus 3. The third step is to set the denominator equals to 0. Where is my denominator? I left only with x minus 3 in the denominator because I have cancelled this x minus 1 with x minus 1. My only denominator is x minus 3 here. So set x minus 3 equals to 0. Just set x minus 3 equals to 0 here. Rearrange the equation, you will get x equals to 3. 3 is my vertical asymptote. Exactly on x equals to 3 I have vertical asymptote. This is gonna be my vertical asymptote. When you come from the right side, the graph goes up in positive infinity. Guys, as you start approaching, you are getting closer and closer and closer. Then the graph diverts up in positive infinity without touching the horizontal asymptote and the vertical asymptote. This graph depends on the nature of your equation and on the value of the left-hand side limit and the right-hand side limit. But suppose you are coming from right side. Your graph is approaching here. And then it diverges up in positive infinity without touching this vertical line and this horizontal line. It will not touch these two lines. Similarly, when you come from the left side, your graph diverges down in negative infinity. So I can simply write that my vertical asymptote is 3. Exactly on x equals to 3 I have this vertical asymptote. To find the whole, pick up this cancelled factor. X minus 1 is the cancelled factor. Set x minus 1 equals to 0 here, which implies that x equals to 1. 1 is the whole here. This is the whole. Exactly on x equals to 1 there is a hole on the graph. When you come from the left side, the graph is continuous all the way up to 1, and then there is a discontinuity, there is a hole, there is a free space. The graph is disconnected here. And then onward, when you cross the hole, again the graph is continuous and it diverges down in negative infinity. So I can write that hole is at 1. There is a hole at x equals to 1. My horizontal asymptote is 0 here because look, the degree of the numerator is less than the degree of the denominator. So according to the rule, horizontal asymptote will be 0. Therefore, horizontal asymptote is 0 here. Exactly on y equals to 0, my horizontal asymptote is 0 here. This red dotted line which has been drawn horizontally is my horizontal asymptote. My vertical asymptote is 3. And then I did factorization. In factorization, I made these two factors out of the denominator. And then I canceled the common factors like x minus 1 with x minus 1. I left only with x minus 3 in the denominator. According to the vertical asymptote, you have to set the denominator equals to 0, which has been left only with x minus 3. When I set x minus 3 equals to 0, I will get x equals to 3. This 3 is my vertical asymptote. Exactly on x equals to 3, 1, 2, 3, positive 3. This is my vertical asymptote. For the whole, you have to set the cancelled factor equals to 0. These are the cancelled factors. For the whole, you have to set the cancelled factor equals to 0. X minus 1 is the cancelled factor. So when I set x minus 1 equals to 0, this negative 1 will go on the other side. I will get x equals to positive 1. This x equals to positive 1 is the whole. Where is positive 1? This is 0, positive 1. Exactly on this point. For the graph, when you come from the left side, there will be the hole. This is going to be the hole. If you want to find the coordinates of this hole at this point, my x is 1. But what about the y? For the y, you have to put x equals to 1 here. When I put x equals to 1 here, I will get 1 minus 3. 1 minus 3 equals to negative 1/2. Negative 1/2 along y-axis. This is my negative 1/2. This is full 1, 2, and the middle part is the negative 1/2. So the point along y-axis will be negative 1/2. 1 comma negative 1/2 is the coordinate point of the hole. Again, I'm telling that this graph will not touch both the vertical asymptote and the horizontal asymptote. If you calculate for the left-hand side limit, when you start approaching from the left-hand side limit, your graph goes down in negative infinity. But when you come from the right side to calculate the right-hand side limit, your graph goes up in positive infinity. Right over here, exactly on x equals to 1, there is a hole. The function is discontinuous. This piece of the graph has discontinuity here. There is a free space. It is disconnected here. So horizontal asymptote is 0, which is this red dotted line. Vertical asymptote is 3, which is this red dotted line. Hole is 1, which is here.